Hello viewers, welcome back to our topic is domain and range of a functions. Okay, so in the last class completely we discussed about that domain of the functions, and we discussed that some particularly the types of the functions, what about their domains. Okay, not okay. Now in this class we are going to discussing about the range of a function, and totally based on that domain and range we will discuss some problems. Okay, first of all, what is the range of a function? What is the range of a function? What is the process to find the range of a function? Yes, so domain of a function means generally, so let us revise that. What is the domain of a function? So the set of values of x, right, the set of values of x for which the f of x can be defined, okay, then that set is called domain of the function. Domain of f of x, am I right or not? That is about the domain of the function. Yes, so for the existency of the f of x, the x values, okay, the set of values of x, we can say that the set is called domain of the function. Yes, for those values of x, for those values of x, so f of x, the function f of x gives some results. Okay, f of x gives some results. Then the set of values of y, I can write like this, the set of values of y, right. So for the function f of x, the set of values of y for the function f of x, I mean, okay, so where the function it can be defined, for those values of x it gives some results. Okay, let us take those values are denoted by y. Okay, then we can write as the set of values of y of the function f of x. So, can say it as a range of the function, right? Understood? Yes, students. So, let us discuss some problems for finding the domain of the functions. Okay, yes, coming to that first problem. So, f of x is equals to square root of logarithm of x factorial base 0.5. Okay, so which is a square root of even function, or even root. Okay, so in that case, what about the value under square root? That should be non-negative, right? So I can write. So for the existence of this function, this can be written as logarithm of x factorial base 0.5 is greater than or equals to 0. Am I right or not? Greater than or equals to 0. So immediately you can write x factorial is less than or equals to 0.5 whole power 0. So logarithmic function transforming into exponential function, here the inequality changed. Why the inequality is changed? Because of the base 0.5, base 0.5 is less than 1. Okay, so in that case this logarithm is called decreasing function. Okay, when the base is greater than 1, that is increasing function, the inequality won't change. Okay, but here base is less than 1, that is why inequality will change while transforming into exponential form. Okay, right? Yes, so simple. So this means x factorial is less than or equals to 1, 0.5 whole power 0, which is 1. Okay, so x factorial less than or equals to which values of x will satisfy? Simply x belongs to 0 and 1 only will satisfy. Okay, right? Yes, very simple thing problem. Okay, yes, coming to the next one. So find the values of x belongs to real number such that which is satisfying the condition, which is logarithm the function. Logarithm the function. Okay, yes, already we discussed this one, domain of a logarithmic function, the function which is associated with the logarithm, that must be positive, right or not? That must be positive. Okay, so this function must be positive. Yes, come on. So let us see. So then I can write 1.6 whole power 1 minus x square is greater than, so the total thing is greater than 0. So which is greater than 0.625 whole power 6 of 1 plus x. Come on, simplify this one. So this is 16 by 10, which is 8 by 5 whole power 1 minus x square is greater than. So what about this value? 625 by 1000. Actually, what is 625 by 1000? So 25 is 25 fourths. Okay, and again 5s and 8s. This is 5 by 8 whole power 6 of 1 plus x. Right or not? 5 by 8 whole power 6 of 1 plus x. Okay, the same thing can I write like this? This can be written as 8 by 5 whole power minus of 6 of 1 plus x. Yes, both sides bases are same, which are greater than 1. Then we can use the same inequality for these powers. So I can write 1 minus x square is greater than minus 6 minus 6x. right or not. So, which is 0 greater than x square yes minus 6x minus 7, x square minus 6x minus 7. Yes, here now we got the inequality, x square minus 6x minus 7 is less than 0, which is x minus 7 into x plus 1 is less than 0, right. And so, product of two factors less than 0, then we can get the value lies between okay, minus 1 and 7. So, okay. So, minus 1 less than x less than 7, this is the value of x, okay, right. That is about the domain of the functions. Okay, come on. So, let us see about that the problem number 3. Yeah, coming to next problem, f of x is equals to square root of logarithm of 2x by x minus 3. Okay. So, it is even root, okay. So, which is never negative. So, I can write the value under square root, which is logarithm of, so 2x by x minus 3 base 10 is greater than or equals to 0, right or not. And one more condition, and the function which is associated with the logarithm, this should be positive, which is 2x by x minus 3 is greater than 0. Okay, come on, simplify this one. So, this is 2x by x minus 3 is greater than or equals to 10 power 0, logarithm form to exponential form, which is increasing function, base is the 10 which is greater than 1, no problem. Okay. So, that is 2x is greater than or equals to x minus 3. So, which is x greater than or equals to minus 3 is one condition. Okay. Yes, coming to this one. So, 2x by x minus 3 greater than 0, 0, simply x by x minus 3 is greater than 0. So, I can write x into x minus 3 is greater than 0, right or not. So, here let us see, a fraction is a positive, a fraction p by q is a positive, that means where p and q numerator and denominator having the same signs, then only the fraction is a positive, clear or not, all of you see this point. So, when p by q is greater than 0, p and q have same signs, that means their product is positive, can I write like this, then p into q is greater than 0, right, like this. Okay. Yes, the same thing I can write, x minus 0 into x minus 3 is greater than 0, x value does not lie between 0 and 3, that means x less than 0 or x greater than 3. Okay, not x less than 0, x greater than 3, that means we can write minus infinity to 0 open interval union 3 to infinity, right. So, finally, what is the common solution in between those two? Right. So, in that case, so minus infinity to 0 here, but here what we can take here, greater than or equals to minus 3 only. So, what is the common solution from this one? I can write including minus 3 to 0, starting onwards minus 3 to 0 union 3 to infinity, that about the domain of the functions. Okay, right? Yes, come on. So, some different problem. Okay, come on, notes, I explained that the fourth one also. F of x is equals to 1 by cube root of, not square root of, cube root of x minus 2 into log 10 base 4 minus x. Okay. Yes, one of the different problem here, this is not even root, this is not even root, this is odd root, cube root of x minus 2. So, there is no problem when the value under cube root is negative, there is no problem, but that is in denominator. So, I can write the conditions like this, x minus 2 is not equals to 0, then there is no problem, this term will exist, right or not. And one more condition here, logarithm of number is already 10, which is positive, but what about the base? What are the conditions for the base of a logarithmic function? So, here I can write, and the base of 4 minus x should be positive, yes, and the base 4 minus x is not equals to 1, right. And please observe this condition, for according to these conditions, then only this function will exist. Denominator x minus 2 is not equals to 0, and the 4 minus x is the base of a logarithm, which should be positive and which is not equals to 1. Then come on, simplify. So, it is x not equals to 2, okay, and 4 minus x greater than 0, x minus 4 less than 0, x less than 4, and here x not equals to 3. Come on, what are the conditions? Total the final values are less than 4. Of those less than 4 values, we should not take 2 and we should not take 3. So, can I write like this? So, the domain is x belongs to minus infinity to 4 first of all, minus infinity to 4. So, in this interval we cannot take, so minus 2 comma 3, not 2 2 3, 2 comma 3, we should not take 2 and 3. Okay. So, like this we can find that the domain of the functions. Okay, not? Yes, come on. So, let us discuss some different problems. In this meanwhile, you can make a note. Yeah. So, what is the range of a function? The set of values of y, the set of values of y for which the function can be defined, okay, for which the function can be defined. So, for those values of x, so it gives the function some results. So, that set is called the range. Okay. So, then let us say I will explain that what is the process to find the range of a function. Okay. To find out the range, compulsory we need where the function can be defined. Okay, the domain should be required. Okay. Yes. So, what is the first step is, so first we should find, okay, so we should get the domain of the function, okay, where it can be defined. That is very most important while finding the range. Okay. And the second one is, okay, suppose if the domain is the finite interval, if the domain is a finite interval, okay, yes, and now the total function f of x, so we are going to transform into in terms of y, making x as a subject, making x as a subject and transform into in terms of y, and transform into in terms of y. Then after where the function can be defined in set of some real numbers. Okay. So, for the existence of that, what are the conditions in terms of y, we should find that value. Okay, understood or not? So, first of all we should find the domain of a function, that is very basic thing. After that, so for that, if the domain is an finite interval, okay, in that case what we are going to do, total the function is transforming into in terms of y, making x as a subject and transforming into in terms of y. Then after where the function can be defined, so for this interval of x, okay, so for which values of y it can be defined. Okay. Yes, we can find that for the existence of the y, what are the conditions, right? Okay. So, let me explain one problem. Suppose f of x is equals to x by 2 minus 3x, suppose. Yes or not? So, what is the domain of the function? Come on, let me see. What is the domain of the function? So, here 2 minus 3x is not equals to 0. So, x not equals to 2 by 3. Am I right or not? Yes, so that is the domain of a function, except all the real numbers we can get that, except 2 by 3 we will get that. Okay, that is the domain of the function. Then coming to range, so that equation is equating to y. So, let f of x is equating to y, that means, okay, x by 2 minus 3x is equating to y. So, x is equals to 2y minus 3xy. Okay. Yes, making x as a subject. So, x of 1 plus 3y is equals to 2y, then x is equals to 2y by 1 plus 3y. Yes or not? Making x as a subject in terms of y. Yes. So, here what is the domain of the function? So, denominator should be not equals 0, then except at x is equals to 2 by 3, then we can define that the function. Okay. Now, making x as a subject, now got the function in terms of y. Yes. Yeah. So, when the function x exists for these values of x, then when the function range values will exist. Okay, right? So, just observe this one. Here also denominator should be not equals to 0. Then what can you say? So, 1 plus 3y not equals to 0. So, y not equals to minus 1 by 3. Yes or not? Yes, range value not equals to minus 1 by 3, then only for this function range will exist. Okay, right? This is the process to find the range of a function. Okay, some problems we can get like this. Okay, let us discuss some more problems. So, how to find the range of a function we will get directly. Okay, let us see. Suppose when f of x is in this form, ax quadratic equation ax square plus bx plus c. Yes. So, for this case, so where a is not equals to 0. For this one, how to get the range of this function? The function is a quadratic expression. Okay. Here when a is greater than 0, already we have the basic idea. When a is greater than 0, so the graph of a function is upward parabola. For this upward parabola, we are going to get that the minimum value. We are going to get the minimum value. Already we know that the minimum value is 4ac minus b square by 4a. We'll get this one. Okay. Then what is the range of this one? So we can write like this, to infinity. So this is about the range of the function. Why? Because already we know about this one. So when a is greater than 0, this is upward parabola. It may be like this or it may be like this, right? So this is the minimum value. Which value is the 4ac minus b square by 4a? Yes, then maximum value we can get something else. Okay, it is up to infinite. Okay, next. So when a is less than 0, what do you say? When a is less than 0, so the graph will get, okay, next. So in that case, this is your maximum value. Okay, so in that case, I can write the range. Range equals to minus infinity to 4ac minus b square by 4a. Okay, in that case, this is called the maximum value. So okay, so when a is less than 0, so we can get the maximum of that quadratic expression. Okay, right? Yes. So this is the one way to find the range of a function. Suppose, and already you know this one, when f of x is a cos x plus b sin x plus c. Yes. So what is the range of a function? C minus root of a square plus b square, c plus root of a square plus b square. Yes. So already we got from the trigonometry. So like this we will get the range of a function. Okay. Yes. So let us see, and we will discuss some problems totally based on that, how to find the domain and the range of a function completely in the objective point of view. Okay, students, come on, have a look. Okay. So let us discuss some problems for finding the range of the functions. Okay, come on. So f from R to R defined by f of x is equals to step of x by 5. What is this? Step of x by 5. So here what is this one? This bracket represents the greatest integer function. Okay, then finally we are going to find f of x, range we should find. So for all x lies between, okay, modulus of x less than 71. What is the meaning of modulus of x less than 71? Means modulus of x less than 71 means x value lies between minus 71 to plus 71. Okay. So already they have given the domain, x lies between minus 71 to plus 71. What is that range? Okay. Yes, so come on, take the values. So here can I write like this, minus 71, that means minus 70 point something by 5, right or not? So we should not take minus 71, minus 70 point something by 5. Okay. Yes, and so on like this, minus 70 point something, minus 69 point something. Okay, not? So all those step values we are going to take, and in between them 0 by 5. Okay, here it is a step of 1 by 5, and so on. The last value is 70 point something by 5. We should not take 71 also. Those are all the range values. So come on, this is step of minus 14 point something, and so on. This is a step of 0, and this is 0 point something, and so on. The last one is 14 point something, right? And so what is the step of minus 14 point something, which is minus 15? The range values we can start with minus 15. Okay, then after minus 13 point something we will get this one. So minus 14, minus 13, and so on, 0, 1, 2, 3, and so on. Yes, whatever this value, step of 14 point something is 14. Okay, not? Yes. What do you say? What is the range of a function? For the adjacency of the x values lies between minus 71 to plus 71. Okay. So what is this f of x? I mean the values which are substituting in this function. Okay. Yes. So that is minus 15 to plus 14. Okay. That is about the range of the first problem. Okay. Yes. So coming to the second one. So it is very clear. The second one is, one quadratic function is given. What is the range of this one? X square minus 4x plus 5. Yes, a quadratic function. So which is upward parabola, right? And so upward parabola, it will get the minimum value. Yes, minimum value. What is the formula for minimum value? So it is 4ac minus b square by 4a is the minimum value. Maximum value we cannot define. Okay. Yes, come on. What is 4ac? 20 minus b square is 16 by 4 come to infinity. So, which is 1 to infinity. Yes, that is all, that is the range of a function. Okay. So, whenever the quadratic expression is given, better to use this one, we will get this easily. Okay. Yes. And coming to the third problem. So, the range of the two functions are given, the range of step of x minus x is capital A and x minus step of x is capital B. What is the intersection part, their intersection parts? Okay. First of all, so coming to the first function, so let us take f of x is step of x minus x. So, before going to finding the range, we need domain compulsory. Okay, not? Yes, in this case clearly already given, it is a quadratic expression, no need of that one, we will get directly range. But coming to this one, f of x is a step of x minus x. So, what is the domain first of all? So, while finding the domain of the function, we need this one, step of x is greater than or equals to x, right, and step of x is greater than or equals to, yes, which values will satisfy, come on. So, all the integers will satisfy, step of integer which gives integer greater than or equals to same integer greater than or equals to. Okay. What about non-integers? Non-integers we cannot satisfy. Okay. Only x belongs to integer, that is about the domain. So, please observe this one, domain. So, while taking that integer, what it gives the results? What it gives the results? Step of x minus x, integer number 5, step of 5 minus 5, which gives always 0. Okay. In that case, so what do you say? The range of the first function f of x is a set of 0. Why? Because the domain is the only integers. Okay. So, coming to this function, second function, x minus step of x. So, let us take g of x is equals to x minus step of x. Okay. Yes. So, g of x is x minus step of x, the range of x minus okay. Okay. Yes. So, when this function will exist, okay, this is g x minus g of x is greater than or equals to 0, x greater than or equals to step of x, right, and yeah. So, which values will satisfy for this one? For all the real numbers, x belongs to the real numbers. Okay, and integers and non-integers will satisfy that condition. Okay. In that case, so for all the real numbers, what it can gives the value? For all the real numbers, what it can gives that? The range of the function x minus a step of x. You can take any real number. Okay, not? So, we can get that the range also, if for all the integers, for x belongs to integer, it gives 0. Okay, not? So, for all non-integers, for x belongs to I, x does not belongs to I, what it can give that? Come on, take that one value, 2.5 minus step of 2, which is a 0.5. Okay. So, we will get that not integer, we will get some real number. So, y is some real number. Okay. The range is all the real numbers. Okay. So, in that case, what is that intersection part is simply I can write to 0. The intersection part is simply I can get the 0. Okay, not? Yeah. So, and coming to that one different problem, okay, which is related to the trigonometric function. Okay, come on. Yeah, what is the range of this function? F of x is equals to 1 by 2 minus cos 3x. So, here the trigonometric function is there. Okay. Can I write like this? Cos values, cos function always lies between minus 1 to plus 1. Cos 3x, cos values, cos angle lies between minus 1 to plus 1. Okay, here I want minus cos 3x. So, totally multiplied with minus. So, 1 greater than or equals to cos of 3x minus cos 3x greater than or equals to minus 1. I mean, multiplying with the negative, we will get that change in inequality. Okay, so please write in order. This is minus 1 less than or equals to minus cos 3x less than or equals to plus 1. Okay. Yes. Then after, so throughout the equation adding 2 for those equations. So, minus 1 plus 2, which is 1 less than or equals to 2 minus cos 3x less than or equals to 3. Right or not? So, adding 2 throughout the equation. Then after, okay, totally reciprocaling that. So, throughout the equation take that the reciprocals of this one, and again inequality will change. So, I can write like this, 1 by 3 less than or equals to 1 by 2 minus cos 3x is less than or equals to 1, which is your function f of x. So, what is this value which lies between 1 by 3 to 1. Okay. So, what is the range of the function is 1 by 3 to 1. Okay, not? Yeah. So, that is the students about some problems for the finding the range of a function. Okay. Yes, so please practice that more some problems from all the models. So, you will get that a clear idea about that domain and range of a function. Okay, please students. So, if you like this video, please share to your friends and your juniors. Okay, your nearby the people, students. Okay, right. So, thank you for watching. So, be ready for the next coming video, and please don't forget that to subscribe my channel and click the bell icon to get all my notifications. Okay. So, be ready for that next upcoming video. Until then, bye bye.